In 4.6, we're going to learn how to solve something with an exponent and logarithms. And there are a couple rules that we're going to have to know in this section. And one of the rules is a very general rule where if you have the same base, which we do here, then you can just say that their exponents will equal each other. And that is only if their bases are the same. So in example 1 here, we have the base of a 5 and base of 25. Now I know that they're not the same right now, but I can change this 25 to say 5 squared, and now we will have the same base. So we still have 5 raised to this. Now we have 5 squared raised to this. And now because the bases are the same, they can cancel out, and we're just left with what the exponents are. So we have x minus 4 equals 2 times x minus 6. Okay, we're going to distribute the 2 to everything. And then we're going to solve algebraically. So we're going to add 4. Minus the 2x. Divide by negative 1. So x equals 8. Here's another example. This time we have two bases, an 8 and a 32. Now I cannot take the base of an 8 and raise it to a power that will equal 32, because 8 squared is 16. 8 to the third power is already 8 squared is 64. And so that's already over what this number needs to be here. So I'm going to pick a different base that I know can be raised to both of them. So 2 to what power will give me an 8? 2 to the third power, and 2 to what power will be 32? And that is the fifth power. We still have x minus 1 and 3x minus 2. So the only thing I did was transform this 8 and 32 to be the same base raised to an exponent that equaled it. Because they're the same, they cancel, and we're left with the exponent. Now we have to do distributive property for each one of these. And use basic algebra to solve it. So add 10. And subtract the 3x. And then divide by 12. In this case, we're going to have x equaling a fraction. Here's another example. And we have a base of 36, and we have a base of 1/6. Now, the 36 and the 6 could go together. And the reason I say they go together is because they're somehow related. They kind of give you a hint in the problem of what number to use as the base. I know that 6 squared is the same as 36. And we still have that 5x plus 2. Now, how in the world would 6 be flipped? Remember, if you have a negative exponent, that is how it is flipped. So I'm going to rewrite this to be a negative exponent raised with the rest of it. Now, because the bases are the same, they cancel, and we're left with everything else. Distribute everything on both sides. So we have 10x plus 4. We have negative 11 plus x. Now we just do simple math. So we can add the 11 and we can subtract the 10. and then divide by -9. So when we do this, we have 15 divided by -9, which can actually reduce, because 3 can go into both, to -5/3. Okay, now we have an example 4 where you are not going to be able to make the base the same. If you look at this, we have 8 raised to x and then 20. You can't use 2 because 2 raised to a number will never equal 20. You can't use 4. I mean, there's nothing that will equal 20 when you raise it to an exponent. When this happens, you're actually going to cancel the 8 out here by just doing the log of base 8. So if we do the log base 8 of 8 to the x power, remember we have to do it on the other side. So log of 8 and then 20. This is the only thing that will cancel this out, and you can bring the exponent down. And then over here, we have log base 8 of 20. We have the change of base formula. So the log of 20 divided by the log of 8. And that is just simply putting that in the calculator and getting a roundabout answer. And the roundabout answer for this one would be about 1.44. Here's another one. Example 5, we have E, which is Euler's number. And we're going to get everything away from the E as much as we can. So first we're going to subtract 16. And then I want to divide by -3. And as you can tell, that 11 over 3 is going to be a decimal. I'm just going to leave it as a positive because there's 2 negatives here. Fraction right now. And then, do you remember how to cancel an E? Hopefully you do. If you don't, you need to look back at your notes. The only thing that will cancel an E is the log of E, which is ln. They don't say log of E in your calculator, they just say the log of natural number, which is the Euler number. So ln is actually taking the log of E. And you have to do it to the other side. So now that we have done that, these cancel and the 2x will come down. And then we can take the ln of 11 over 3. You can get your decimal number and then divide it by 2. So the ln of 11 over 3, I'm just going to write this. And then divide everything by 2. And the answer that I get is around 0.65. All right, now the last rule that we have is, remember in the first rule we said that if we had the same base on each side of the equation that you could cancel it out and bring down the exponents. The same thing goes for the log. As long as these bases here are the same on each side of the equal sign, then you can cancel them both out and put whatever's left to set it equal to each other. For example 1, notice that we have the log base 5 and the log base 5. They cancel and we're left with 5x plus 9 equals 6x. We can solve for x by simply doing algebra. And so 9 equals x. Example 2, remember the log of E is ln. So you have the log of E on both sides, cancels, and we're left with this. So we're going to simply do algebra and figure out what x is. and x equals 6. Example 3, again, if you don't have the log base 4 on both sides, you can't cancel it. So what we can do here, the only way to cancel a log of base 4 is to take that little base and raise all of this. So the base raised to log 4 will cancel, but remember you have to do the 4 raised to negative 1 on the other side. So when you do this, this cancels and the x is left. Now, 4 raised to negative 1 is just a fraction flipped. So here is your answer. Same thing with ln. If you don't have an ln on the other side to cancel, the only way to cancel it is to take the base of that log. And remember, ln is really the log of base e. So we need to take e and raise all of this as an exponent. But there's one step that I did not do before I could raise the e to each side. And I want you to figure out this step. And if you can write it in your notes, what step that I missed, and have it ready when I go around and give extra credit, I will give you 1 extra credit more on top of the 2 that I give you for this section. And then we will discuss this afterwards in class together. So I will not complete this example just to save you watching the video all the way through.